Hello and a very good morning wherever you are. I am Mohan Kasuri. Let me welcome you to this course whose title is Physics Principle and Application. This course consists of 5 chapters. Fifth is Application of Electromagnetic Wave. This course is basically intended for undergraduate students. FYBC. I am presenting PowerPoint for FYBC Chapter 5 Application of Electromagnetic Waves. Electromagnetic radiation is of many types and it constitutes electromagnetic spectrum. Electromagnetic spectrum consists of radio waves, microwaves, infrared waves, visible light, ultraviolet radiation, X-rays and gamma rays. Electromagnetic waves accomplish the transmission of energy through vacuum or using no medium. What are electromagnetic waves? Electromagnetic waves are waves that travel through vacuum like in space. This is possible because they are not vibrations in an actual material. They are fluctuation in electric and magnetic fields. Example of electromagnetic waves include radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves have the lowest energy and frequency and the longest wavelength. Gamma rays have the highest energy and frequency and the shortest wavelength. Microwaves have probably the most obvious application in an microwave. Microwaves can be used to heat and cook your food. Since microwaves are not that different from radio waves, they have also been used for communication, especially for extending TV signals to larger distances. Infrared waves are what comes out of remote controls. Infrared is also a type of wave that transmits a lot of heat when you put your hand near to but not touching something and it feels warm. It is because of infrared waves coming out of it. All hot objects produce infrared. This is a model microwave oven. Structure of microwave oven. The basic principle of microwave oven is to generate microwave radiation of appropriate frequency in the working space of the oven where we keep food. The energy is not wasted in heating up the vessel in the conventional heating method like that. In microwaves, energy is directly delivered to water molecules which are shared by the entire food. Here the magnetron to source of radiation. Then this own cavity is a filter, a step of transformer and a power plug and waveguide here this as mode steerer. When microwave ovens became popular in the 1970s, they lifted household convenience to a new level. A conventional oven heats food very slowly from the outside in, but a microwave oven uses tiny, high-powered radio waves to cook food more evenly. This is why a microwave can cook a joint of meat roughly 6 times faster than a conventional oven. Microwave ovens also save energy because you can cook immediately without waiting for the oven to heat up to a high temperature first. Let's take a closer look at how they work. How does microwave turn electricity into heat like this? Inside the strong metal box, there is a microwave generator called a magnetron. When you start cooking, the magnetron takes electricity from the power outlet and converts it into high powered 12 centimeter bracket 4.7 inch radio waves. The magnetron blasts these waves into the food compartment through a channel called a waveguide. The food sits on a turntable spinning slowly round so the microwave cooks it evenly. The microwaves bounce back and forth off the reflective metal walls of the food compartment, just like the light bounces off a mirror. When the microwave reaches the food itself, they don't simply bounces off, just as radio waves can pass straight through the walls of your house. So microwaves penetrate inside the food as they travel through it. They make the molecule inside it vibrate more quickly. Vibrating molecules have heat, so the faster the molecules vibrate, the hotter the food becomes. Thus, the microwaves pass their energy onto the molecules in the food, rapidly heating it up. How microwave ovens work? The invention of the microwave is a fantastically simple concept. Microwaves have a frequency that can penetrate water, fat, and sugar molecules and excite them. For a molecule to be excited, the electron orbiting the nucleus have to jump up higher of energy levels. When this occurs, the atom starts to vibrate faster than normal. When this happens in a glass of water, for example, all the atoms that make up water start to move and run into each other and create friction. When friction is created, energy is given off in the form of heat. Radar is a detection system that uses radio waves to determine the range, angle, or velocity of object. It can be used to detect aircraft, ships, spacecraft, guided missiles, motor vehicles, weather formation. A radar system consists of a transformer producing electromagnetic waves in the radio or microwave domain, a transmitting antenna, a receiving antenna. Often the same antenna is used for transmitting and receiving, and receiver and processor to determine properties of the objects. Radio waves pulsed or continuous from the transmitter reflect off the object and return to the receiver, giving information about the object location and speed. Radar was developed secretly for military use of several nations in the period before and during World War II. A key development was the cavity magnetron in the United Kingdom, which allowed the creation of relatively small system with a sub-meter resolution. The term radar was coined in 1940 by the United States Navy as an acronym for radio detection and ranging antenna radar systems. Here, the antenna sends signals to target. Target reflects back the signals, and here transmitter a power amplifier or power oscillators, and this is a receiver system here. This receiver to the decision making unit, and this decision making unit, and this is the output. Is clear of the idea. Given below are the six major parts of radar system. Transmitter. It can be a proper amplifier like a klystron, traveling wave, tube or power oscillators like a magnetron. The signals is the first generated using a waveform generator A and then amplified in the power amplifier. The waveguides are the transmission lines for transmission of the radar signals. Antenna. The antenna used can be parabolic reflector, planar arrays, or electronically steered phase arrays. Duplexer. A duplexer allows the antenna to be used as a transmitter or a receiver. It can be gaseous device that would produce a short circuit at the input to the receiver when transmitter is working. Receiver. It can be super heterodyne receiver or any other receiver which consists of a processor to process the signal and detect it. Threshold decision. The output of the receiver is compared with the threshold to detect the presence of any object. If the output is below any threshold, the presence of noise is assumed. What does radar use radio? Whether it's mounted on a plane, a ship, or anything else, a radar set needs the same basic set of components, something to generate radio waves, something to send them out into the space, something to receive them, and some means of displaying information so the radar operator can quickly understand it. Pyroelectricity, from the two Greek words pyr, pyre, meaning fire, and electricity, is a property of certain crystals which are naturally electrically polarized and as a result contain large electric fields. Pyroelectricity can be described as the ability of certain materials to generate a temporary voltage when they are heated or cooled. The change in temperature modifies the position of the atom slightly within the crystal structure such that the polarization of the material changes. This polarization change gives rise to voltage across the crystal. If the temperature stays constant at its new value, the pyroelectric voltage gradually disappears due to leakage current. How does pyroelectric sensor work? Pyroelectric detectors are thermal detectors. Temperature fluctuation produces charge change on the surface of a pyroelectric crystal, which produces a corresponding electrical signal. The pyroelectric coefficient determines the ability to produce current from infrared radiation. That is to say, the bigger the better. Pyroelectricity and application. Pyroelectricity is the property of a material to produce electrical energy when they are subjected to thermal energy change. Pyroelectric crystals are those possess the pyroelectric effect, that is the ability of crystal to generate electricity when they are heated. When pyroelectric materials are heated or cooled, heat polarization in proportional to the change in temperature. As a result, the crystal generates an opposite polarity that creates a short period of electrical potential difference or a temporary voltage. The points that generate a particular polarity can also generate a reverse polarity at the same location when it has applied with the negative temperature. That is, the charge polarity developed on location during the heating will be reversed during cooling. X-ray radiography. X-ray or radiography uses a very small dose of ionizing radiation to produce pictures of the body internal structure. X-ray are the oldest and most frequently used form of a medical imaging. They are often used to help diagnose fractured bones, look for injury or infection, and to locate foreign objects in soft tissue. Some X-ray exams may use an iodine-based contrast material or barium to help improve the visibility of a specific organs, blood vessels, tissues, or bone. Description. It is used to diagnose or treat patients by recording images of the internal structure of the body to assess the presence or absence of disease, foreign objects, and structural damage or abnormality. During radiographic procedure, an X-ray beam is passed through the body. It is used to diagnose or treat patients by recording images of the internal structure of the body to assess the presence or absence of disease, foreign object, and structural damage or abnormality. During radiographic procedure, an X-ray beam is passed through the body. A portion of the X-ray are absorbed or scattered by the internal structure and remaining X-ray pattern is transmitted to a detector so that an image may be recorded for later evaluation. The recording of the pattern may occur on a film or through electronic means. Uses radiography is used in many types of examination and procedures where a record of a static image is desired. Some example includes dental examination, verification of correct placement of a surgical makers period to invasive procedures, mammography, orthopedic evaluation, short film or static recording during fluoroscopy, chiropractic examination. The term computed tomography or CT refers to a computerized X-ray imaging procedure in which a narrow beam of X-ray is aimed at a patient and quickly rotated around the body, producing signals that are processed by the machine's computer to generate cross-section images or slices of the body. These slices are called tomographic images and contain more detailed information than conventional X-ray. Once a number of successive slices are collected by the machine computer, they can be digitally stacked together to form a three-dimensional image of the patient that allows for easier identification and location of basic structure as well as possible tumors or abnormalities. Benefits of CT include more effective medical management by determining when surgeries are necessary, reducing the need for exploratory surgeries, improving cancer diagnosis and treatment, reducing the length of hospitalization, guiding treatment of common conditions such as injury, cardiac disease, and stroke. The following are the different types of solar cells. Solar cells: amorphous silicon solar cell, ASR, biohybrid solar cell, cadmium telluride solar cell, CDTE, concentrated PV cell, CVP, and SCPVP, copper indium gallium arsenide solar cell, CRGS, crystalline silicon solar cell, CAS, and flat zone silicon. A solar cell, also known as the photovoltaic cells or PV cell, is defined as an electrical device that converts light energy into electrical energy through the photovoltaic effect. A solar cell is basically a p-n junction diode. Solar cells are a form of a photoelectric cell defined as a device whose electrical characteristics such as current, voltage, or resistance vary when exposed to light. Individual solar cells can be combined to form modulus commonly known as a solar panel. The common single junction silicon solar cell can produce maximum open circuit voltage of approximately 0.5 to 0.6 volt by itself. This is not much, but remember these solar cells are tiny. When combined into a large solar panel, considerable amounts of renewable energy can be generated. P-n junction solar cells. The diagram is see here. First one, P-type and N-type. This is a P-type material. This is a N-type materials. And P-type and N-type material are some region we call it as depletion regions. And this is a back electrical contact. And this is a front electrical contact. These two contact here. And then we find here the electrons and here the holes. Produce this p-type and n-type. We electron in n-type and p-type in holes. And just photon is incident of this one. Here photon absorbed in a depletion zone. Electron hole creation. And this for electron hole creation, there flow of this charge working of principle of solar cell. When light reaches the p-n junction, the light photons can easily enter in the junction Through very thin p-type layer, the light energy in the form of photons supplies sufficient energy to the junction to create a number of electron hole pairs. The incident light breaks the thermal equilibrium condition of the junction. The free electrons in the depletion region can quickly come to the n-type side of the junction. VI characteristic of photovoltaic cell. Photovoltaic array voltage or current characteristics. Here this diagram is x-axis is voltage and y-axis is current in amperes. And see the diagram here. This point is short circuit current. This point is short circuit current, and this is open circuit voltage. And we draw this is the maximum power point. This point, maximum power point. We draw these lines here. This is maximum current. We draw these lines here. Is a voltage maximum. Is a voltage maximum. Material used in solar cells. The materials which are used for this purpose must have band gap close to 1.5 electron volt. Commonly used material are silicon, gallium arsenide, CDT, Cu, Nr, Ac2. Advantages of solar cell. First, no pollution associated with it. Second, it must last for a long time. 3. No maintenance cost. Disadvantages of solar cell. First, it has a high cost of installation. Second, it has low efficiency. Third, during cloudy day, the energy cannot be produced, and also at night we will not get solar energy. Uses of solar generation system. It may be used to charge batteries used in a light meters. It is used to power calculators and wrist watches. And fourth, it can be used in a spacecraft to provide electrical energy. The fill factor is essentially a measurable of quality of the solar cell. It is actually by comparing the maximum power to the theoretical power that would be output at both the open circuit voltage and short circuit current together. The basic characteristics of solar cell are the short circuit current IC and the open circuit voltage VOC, the fill factor and the solar energy. Conversion efficiency is the influence of the both the diode saturations, current density and of IC on a VOC. FF on eta is analyzed for ideal solar cells. The following are the different types of solar cell: amorphous silicon solar cell, biohybrid solar cell, cadmium fluoride solar cell CDT, dysynchronized solar cell DSSC, copper indium gallium arsenide solar cell CIGS, crystalline silicon solar cell CISN, gallium arsenide solar cell GASN, hybrid solar cell, polycrystalline solar cell multi SI. Solar electricity. This is one of the solar energy application that has gained a lot of momentum in recent years. Solar water heating. Uses for solar energy extended to the water heating system, solar heating, solar ventilation, solar lighting, portable solar transportation. A solar vehicle is an electric vehicle powered completely or significantly by direct solar energy, usually photovoltaic PV cells contained in a solar panels convert the sun energy directly into electrical energy. Solar home lighting system. Solar home lighting system SHLS is the best solar light for home purpose. These lights harnesses the sun's energy to light up your home and power your small appliances. This electricity is stored in the solar battery and used for lighting whenever required. Thank you.